Guys, welcome to Guide Academy. So in this tutorial we are going to design a water tank which is used in our home for water storage, a polyethylene material water tank. We will try to do its hydrostatic pressure analysis. We will see its manufacturing processes and we will try to make a die for manufacturing. So let's start and proceed to part design. You can rename it here as water tank or whatever you want. Okay, then select the sketch here and select a plane here and follow the steps what I am doing. Just select this profile icon and try to make a L section and double press on escape. So provide constraint here. So this value is 1070 by 2 and this is 1040. So these are some dimensions of my water tank. I will provide a fillet here in between these two lines of 100 mm. Okay, now select the reference line here. Before that, click here on normal view as my orientation. Okay, wait a minute. As you can see, this plane is not been in perfect view, so this may be because my render style is in parallel. Oh, sorry, perspective. We need to change this in parallel. So you can see now it is perfectly aligned. Okay, now select this point and make a reference line and provide the dimension of 1250 mm. Okay, let it be 1200 mm and then draw a horizontal line of 200 mm. Select this 3-point arc and make a arc here. Okay, and provide fillet here. Let this be 100 and let this be 425. Okay, so this is my basic shape of water tank. Now I will just close this figure by drawing a line here and then exit. Now sharp this figure along this axis, so it has already defined the axis and figure. So this is my basic shape of water tank. Now I will select this plane and click here on sketch. Now make a reference line here from this central axis and this must be of 1070 by 2. That is our radius of this water tank, and make a circle here. Okay, provide dimensions here. This is 25 and cut this by a symmetrical line. Select here union trim and trim this shape. Okay, also trim this. Now select this sketch and click here on translate and select a point here and select the instance how much you want to translate. So I will select here suppose 10. So my this whole semicircle number will be 11 because I have selected duplicate mode also. Okay, now exit the sketch and again press here on shaft, select the axis and preview. Okay, now again select a plane here. So I will just select this plane, click here on sketch and select this circle and project this. Now you need to isolate this sketch. Again, make a circle here. Of, let it be 575 mm. Okay. And then make a rectangle here. Let this be 150 mm and make this symmetrical along this axis. That is 75 mm. Okay. Now click here on unit trim command and trim this. Press here on X cap and select the sketch. Okay. Let trim this also and trim this also. Now press here on escape and select the sketch and click here on rotate command. Now select a central point and select a axis, a reference axis with respect to which you want to rotate your figure. And I want three similar figures, so I will just press there 3 and rotate that by 90 degree. So you can see this is my figure. Now again make a circle here. Okay. And click here on trim command and trim this, trim this, trim this, as well as trim this, also this, trim all this inner parts. Press here escape and again make a circle. Let this be 450. Okay, and then exit the sketch. Now click here on pad and in reverse direction and just drag this. Click here on preview and then OK. Wait a minute, just drag this above also. Preview. Okay. Okay, so we need to provide fillets here. So click here on fillet command and provide a fillet at each corner, so that when we are doing the blow molding, the material must flow smoothly through corner. So just select all the corners and provide fillet. Okay, press here on OK. And we have filleted all the edges, so this edge is left. Just fillet this also. Select all these 4 edges and fillet that. Click here on preview and then OK. Now you need to shell this, so select shell command and select the surface, and you may put here thickness of 5 mm and then press OK. Okay, so you can see our water tank has been made. Now we can do its pressure analysis, hydrostatic pressure analysis. So before that you need to save this file. So just click here on file and just save this file. Guys, I have saved the file in step format. Now we will try to do its hydrostatic pressure analysis. So just drag this static structural here and define engineering data by double click on it and select this engineering data sources and select here grant a design sample material, and then select see your material here, that is polyethylene HDPE. Search for that and just press on this add icon. Okay, this is my material. Now you can just close this engineering data and you can import your geometry by right clicking on this geometry and just selecting your file. You can also view your file by pressing on design modular. Okay, so our design modular has been opened, but you can see there is no file here. So you need to click here on generate so that it will read the step file and import the file. So our file has been imported. You can see this is our file. Close this and open model. Double click on model and let it open. Okay, so model has been opened and our file has been imported in this static structural analysis to box. Now we will change the material here from structural steel to polyethylene HDPE. Okay, now next step is to create mesh. So click here on generate mesh. Okay, so mesh has been created. Now we will apply boundary conditions. So first is our fixed support. This base will be fixed. So click here on face and select this face. Now we will insert hydrostatic pressure in this water tank. So just click here on x-axis and just cut this along a plane for selection purpose. Okay, now click here on face selection command and then just drag this by clicking your left button of mouse. Okay, my water level will be up to this side, so I will select up to this. You can select more further. Now just untick this section plane and you can see selection has been made. You need to apply here fluid density. So our density of water is 1000. You can press here 1000 and then apply gravity here. So just choose component and in Z direction you can apply your gravitational water acceleration. Now you need to assign the free surface of water. As you can see, our coordinate system is here. From here, with respect to here, you need to assign a free surface. So our free surface from this base will be nearly about 1200 mm, that is 1.2 meter. Okay, every dimension here is in meter. You can change your dimension from here. Now you can see how the pressure is varying here. Okay, so click here on solution and you can insert here deformation, that is total deformation. You can insert bond misses stress as well as many more things and click here on solve. So our solution has been done and you can see how our stress is acting in this tank, how this deformation is being done. You can change your material units here to mm and see 1.16 mm deformation is being made here. as well as stress. 1.17 MPa stress is been applied to this region. Okay, now we will see how this tank is being manufactured. What is the process of manufacturing? So just close this. So this is manufacturing process of a tank. You can see there are two dies and a melted part is inserted in these two dies and air is blown in between that. And this is how the tank is manufactured. So guys, we will see how to create a die for blow molding. So I will proceed to assembly design and then open our part here, that is my water tank, and this is the profile. Now you need to double click here on water tank, okay, and then go to generative shape design. Now here there are many icons. You need to click here on this multiple extract. Okay, you will get behind this boundary multiple extract. Now select all these faces, all the outer faces. Okay, select everything. Don't leave a vacant gap here. Select everything. Okay, I have selected each and every outer face. Just again verify that none of the face has been left for selection, or it may create error and you have to again do process. So all of the faces have been selected. You can click here on OK and then click here on fill command. Okay, this is my fill command. Select this circle and click OK. Now click here on join command and in part body select this multiple extract and fill and click here on OK. Now you can see this is our surface. Now go again to product and insert a new part here. Click here OK. The part has been inserted. Double press on this part and then select a plane here. Before that, proceed to part design and then select a plane here. Now you need to make a rectangle here. Okay, you can provide constraints also. So let this be 650. Let this be 13. So 1350. Let this be 50. Okay, and then exit. Now click here on pad and press multiple extend and extend this. Extend this up to 630 and click here on OK. Now select this split command and select this joint one. Click the outward direction and click here on OK. Okay, so our cavity has been made. To see this cavity, you need to hide this object and you can see our die has been made. Now you need to create entrance here. So for that, select this, select any of the surface here. Okay, and just select this and project this surface. Project this sketch, sorry. Click here on normal view and just close this sketch, exit, and then pocket this. Okay, so you can see our die has been made. Similarly, we will try to make another one. So again, double click on product and insert a part here, new part. Okay, and then double click on this part too. Now select a sketch here, again select this plane and make a rectangle here. That's it. You can give constraint similarly. Okay, so let me find what is this dimension. So this is 650. Okay, and then you can coincide this, delete this and coincide this with this. Okay, now click here on exit and then pad this also. Mirror extend till 625, I think so. Okay, click here on OK and then again click here on split command, select this joint one, select the outward direction and click here OK. Now again we need to create a cavity here, so select this plane and select this project this circle and then exit and then pocket, click here OK. Now you can see our die has been created. You can just move this, click here on move and then move this along y axis. So this is how the die are created in catia. Now this die can be machined in catia itself. We can extract a G code from here in catia and then in machining you will get surface machining, prismatic machining. There are various types of machining. From here you can get CNC codes and then this CNC code can be inserted in CNC machine and this die can be manufactured. So this is very easy process. So that's it.